Today we'll study the conversion of the potential energy into the kinetic energy. So let's start with a picture. So what we have here is some cliff. Here is the ground, and then at the top of the cliff we have some block. Okay, and this block has a mass m. Now the total energy of the system is E, which is equal to the potential energy plus the kinetic energy. Now let's look at the potential energy. The potential energy is just the mass times g and times the height. And here is the height of the cliff times the height of the cliff. And here is the height of the cliff. Now the mass doesn't have kinetic energy, because you can see the block is just sitting there. So at this point K is just equal to 0. We don't have K, all we have is U. And E is equal now to U only. Now if we use our imagination, we can think of, at the beginning we have two buckets. We have one bucket of the potential energy, it's called the potential energy bucket, and then we have another bucket of the kinetic energy bucket, we call it K. So at the beginning what we have only the potential energy, okay, and that potential energy will fill up this bucket here, and the kinetic energy is 0 because the block is not moving. Now when the block falls down, let's see, the block gets halfway here somewhere. Let's see, this is the height, here is called h over 2. This is the height, h over 2. So now at this moment the block is moving, so it has some velocity v, and also it has certain height, which is h over 2. So now the total energy has both the potential energy, which is mgh over 2, since we have only have the height, and we also have some kinetic energy, which we call half mv squared. So now if we look at the idea of the buckets again, the potential energy now is a bucket is half full. You can see that we have half the potential energy, and now this kinetic energy bucket will have some energy in it. Why? Because you can see that some of the potential energy lost here, that potential energy that got lost halfway, it got converted to the kinetic energy that's in this bucket here, K. Okay, so now when the block got here closer or right before it hits the ground, so it has some velocity we can call v final. At this moment the block doesn't have potential energy, because you can see h is almost 0, or 0 is about to touch the ground, or really right before they touch the ground. So the potential energy bucket will be empty, nothing in it. But when we look at the kinetic energy bucket, the kinetic energy bucket will be completely full, because all of that potential energy at the beginning got converted to the kinetic energy, and the total energy now is equal to half mv squared. So the total energy conserves by definition. So the potential energy that we started with, which is mgh, is equal to the kinetic energy that we ended with, which is K. So mgh is equal to half mv squared. And from this equation you can see that we can calculate the velocity. The mass cancels out, and we can know the velocity of the object right before it hits the ground. So from this equation we can know the velocity of objects when they fall. Let's see, if an object falls from a building or something, we can know its velocity right before it hits the ground, just by knowing the height. Of course, we need to know the gravity, and we know that g is just 9.8 meters per second squared. Okay? So what we learned today is that the kinetic energy and the potential energy, actually they exchange. What was a potential energy became now kinetic energy. And you can also go backward from kinetic energy to potential energy. If you lift this object up, what happened, it will gain potential energy, and then will lose kinetic energy. If you throw it up, it's gonna stop somewhere here, which means the kinetic energy will be zero and the potential energy will be maximum. But these two energies are equal to each other because the total energy is conserved. So what we have to write at the end is that mgh is equal to half mv squared. And from this equation here, we can actually know the velocity of the block when it hits the ground. You don't need to know the mass. Look, the mass cancels out. So we can actually calculate the velocity of the block when it hits the ground. So what we learned today is that the potential energy that we started with got converted to kinetic energy that we ended up with. So, and the total energy didn't change. You see, the total energy is conserved. If we neglect friction, of course there is a friction, but if we neglect it, we'll have the same energy at the top as at the bottom.